check the conditions for IVT, there's only two of them, and they're actually pretty easy to check. The first one is this function continuous on the interval? So I'm going to type this out instead of write it, since my handwriting is a little bit atrocious sometimes on a pen tablet. But we're going to say, since f of x is a quadratic function, then we know that it's continuous at all real values. Continuous, if I could spell here, continuous for all real values of x. That's our first condition. So it's continuous, IVT holds on that part. Now we need to check the endpoints and make sure that the value we're interested in, which is 0, we're interested in the function equaling 0. We got to make sure that's between the value of the function's endpoints. So we have to find f of 0 and f of 2. Well, it turns out that f of 0 is negative 1, which is less than 0, which is what we're interested in, the y value, which is less than f of 2, which equals positive 1. Oh, f of 0 is negative 3, not negative 1. Get out of here. There we go. So these are the conditions we just checked. Is the function continuous? Yes, it is. It's a quadratic, so it must be continuous. That's here. And is the value we're interested in 0 between the value of our endpoints? And f of 0 is negative 3, f of 2 is 1. So basically, if you're going to draw a picture here, f of 0 is down here, 1, 2, 3, right here, negative 3. And f of 2, 1, 2, is 1. So since our function is continuous, these have to be connected, and somewhere in here, the function has to equal 0. And that is exactly what we're going to say. Since the conditions are met, IVT holds, and f of some value, we'll call it c in this case, f of c equals 0 for some value of c. So again, I'm going to type this out, but the first part, check your conditions, and the second part, just write out what IVT says. Since the conditions are met, IVT holds for f of x on the interval 0 to 2, and there must be some c where f of c, not copyright, get out of here, where f of c equals 0 on that interval. That is what our IVT says. Okay, the conditions are met, IVT holds for f of x on the interval, and there must be some c where f of c equals 0. Now, it says explain why. We just did that right there. We checked the conditions, they hold, f of c must be 0 somewhere for some c on 0 to 2, and we got to find the 0. So finding the 0 has nothing to do with IVT, really. IVT just says that there is a 0 between 0 and 2. To find it, we got to do a little bit of algebra. I'm going to say x squared minus 3 is equal to 0. Well, that means x squared is equal to 3. And that means x could be plus or minus root 3. Now we have two answers here. But remember, we're looking for a value between 0 and 2, which means we don't want negative root 3. The only value that works, and you can see I just connected these dots on my graph here, but right where it hits 0, that's going to be root 3. So the value we're looking for is root 3, not negative root 3. And I'm just going to write it out. So c is equal to positive root 3. There you go.